In this section, we're going to create a small GraphQL application with Python and Graphene. Graphene is the tool that allows us to use GraphQL in conjunction with Python. We'll begin in the command line or terminal, where we'll cd into the part of the computer that we want to create our project in. Next, we'll make a new directory for our project called python-graphene. We'll cd into this folder, and we'll create the file that our project's going to run out of, which will be called schema.py by running touch schema.py. Finally, we'll open this folder in our code editor. Once our project's been opened up, we'll run the command pipenv shell. This command will do two things for us. First of all, it's going to create a virtual environment for our project. You can see that you're in your virtual environment if your project name is wrapped in a set of parentheses. And it's also going to create a pip file for us. The pip file will be helpful in managing any packages that we bring into our project. Note that if you want to exit your virtual environment, you can run the command exit, and to re-enter it, just run pipenv shell again. Our project's going to have only one package, and we can install it with pipenv install, and the name of the package is Graphene. Once we see that Graphene's installed, it should be added to our packages area in our pip file. Now let's head to schema.py and import Graphene up at the top. We'll kick things off with a simple hello world. We'll create a query called hello that returns the string world. To create our first query, we need to create a root query type, and that's done by creating a class called query that subclasses from graphene.objectType. The field for our first query will be called hello, as we mentioned, and the data type that it will contain is going to be set to graphene.string. We can get all of the GraphQL scalar types from Graphene. So we've specified the field and data type for this query, but how's it going to be resolved? How are we going to get the string world returned from it? We can do so with the help of a resolver function, which is a special kind of function specific to GraphQL operations, which will resolve the operation. The name of query resolver functions have to be prepended with the word resolve, and it's written in snake case, so it's going to be resolve_hello. Resolver takes self and info. We'll touch on these two values later. For now, we just want to return the string world. Now we need to create our schema based off of our root query type. We can create that with graphene.schema and pass in our query class. We'll store our schema in a variable called schema, but to actually execute this hello query, we can say schema.execute and then pass in our GraphQL operation as a string. And I'm going to use a set of 3 single quotes so we can put this in on multiple lines. We'll write our query in the normal syntax by opening up a set of curly braces and providing the name of it, hello. We'll store the return value in a variable called result, and we'll print the result to the terminal by printing result.data.items. Now we can save schema.py and run this in our terminal with python schema.py. And we get this odict items, as well as the name of our operation and its resolved value. If we just wanted to get the return value, we could replace result.data.items with result.data and then provide the name of the operation, in this case, hello. So if we save and rerun this, we just get world. But to put this in a more appropriate format, to put this in a JSON format, which we would normally expect from a GraphQL operation, we can first of all import JSON up at the top, then we'll convert result.data.items to a dictionary. We'll store this value in a variable called dict_result. Then we'll use json.dumps to convert our dict result to JSON. and finally we'll print it. So if we save and run schema.py, we get hello world in JSON. And if we want to better format this, we can set the indent within json.dumps, and I'll indent each line by 2. So whenever we execute an operation, and I made a small error, whenever we execute an operation, since it's indented, it's much more readable.